In the last session, we have discussed what are the differences between a file system and a distributed file system and a Hadoop distributed file system, and what are the advantages and disadvantages of file system, distributed file system, and what is the solution, came in the form of Hadoop distributed file system. So, just to have a review on it, what we can say is file system cannot or else file system, distributed file system, Hadoop distributed file system. So, when it comes to storage, file system cannot do huge amounts of data storage. So, it cannot do huge amounts of data storage, and when it comes to processing, no, it is not a good fit for even processing as well. And when it comes to data loss, yes, there is a data loss in the file system. And when it comes to concept of metadata, no, there is no concept of metadata here. So, these are the 3 points, or these are the 4 points where we have to understand what is the difference between file system, distributed file system, and Hadoop distributed file system. Here again, when we talk about the distributed file system, so we cannot store humongous data again in distributed file system, though we can distribute a file, but we cannot store so much of data on a single file system. And again, when it comes to processing, no. When it comes to data loss, yes, there is again data loss, again there is no concept of metadata here. Now, the next and the final one is Hadoop distributed file system. When it comes to storage, yes, you can store any form of data and any volume of data, right? And the processing, no, we cannot do. Of course, though we can do, that comes in the form of map reduce. But Hdfs, when you speak of Hdfs, it's only for the storage, not for the processing. Again, on the whole, if you speak about the Hadoop and its processing, yes, there is something called as map reduce. And again, when it comes to data loss, there is no concept of data loss here. There is no concept of data loss because each file in Hadoop or each file in Hdfs would be divided as blocks, or each block again would be replicated. So, 3 copies of the same data would be stored on Hdfs. So, replication factor, we will call it as replication. So, there is a concept of replication available in Hadoop distributed file system, and there is a concept of metadata. Yes, there is a concept of metadata. So, these are the advantages of Hadoop distributed file system. So, here again the question to understand is what is so special about dividing a file? How Hdfs actually hosts huge volumes of data? Why the processing is so fast when it comes to Hadoop distributed file system? Here we will be studying some important points pertaining to file system or the operating system, how actually the data would be divided when it actually starts processing. For example, as we have been saying, as we have been learning, each operating system consists of file system. Each operating system consists of file system. So, every file system actually helps to process certain amount of data in order to make processing very fast. So, everything is interlinked. So, you have a file and you want to process it fastly. So, what I will do is I will submit to the particular operating system. So, in turn operating system would have a file system. Again, that file system do certain things in order to have my file processed quickly or fastly. So, as every file system actually has a concept of block size. So, remember, this is file system has a concept of block size. No matter what kind of file system you take, either you take a disk operating system, or you take Windows operating system, or a Macintosh operating system, or a Unix, any flavor of Unix operating systems, there is a concept of block size inside the file system. Now, what is a file system for Windows? File system for Windows, the latest editions of Windows have a file system called as new technology file system. And what is the file system of Linux or all the flavors of Linux. ext extension, ext, again ext4, ext5, and there are certain configurations again here. So ext is the file system for Linux. So ext is the file system. What is the file system for Hadoop? Hadoop file system is Hadoop distributed file system. Hdfs is Hadoop distributed file system, and for Macintosh file system. So each file system would have a concept of block size. Each file system has a concept of block size. That means whenever you submit a file to a file system, your data would be actually divided. So that's when the concept of file allocation table would come into picture. So in the older version, the older versions of Windows NT or Windows 98, so each file that you process would be divided in form of a block. So when I say FAT12 or FAT16 or FAT32, that means each block of your file would be processed in form of 12 bits or 16 bits or 32 bits. So no matter how big your file is, when you look at the processing or when you look at the processing of the file, that file has to be divided either 32, 16 or 12 depending on the operating system that I am using. Now let us imagine I have a huge file and my file system actually has a file 32 or a file 16. Obviously, though I have a big hard disk, my processing speed or processing of the file has not kept up that in par with the hard disk capacity. So what happens? Obviously my processing would be a little slower. So no matter how much data, no matter how lot of data that I can store, but the processing, when it comes to processing, I cannot store so much of data on it. Now let us talk about the new technology file system. Again, NTFS has a little advanced version of the block size. So generally NTFS has a block size of 512 KB and so on. Again it depends, again it is configurable, again it depends. To understand what is the role of the file system, let us say it is 512 KB. So each file, it is only for the understanding what is the significance of the file system when it comes to a block or when it comes to processing a file. It can be 512, it can be 1 KB, it can be 512, it can be above this as well, So I am sorry here, yeah, 512 KB. So above this as well. So here it can even increase. So 512 KB. So each block or each file again would be divided as a 512 KB of block size. Now imagine from 32 to 512 KB. So obviously the processing would be a little fast. Actually that's when everybody started buying Windows. Other than its GUI property, this is one of the properties that everybody actually looked at NTFS. So new technology file system, it actually changed, Windows actually changed how you look at the computer. The perspective of looking at computers is almost changed when Windows got into the IT world. Now let us take Unix file system. All the flavors of Unix file system, they are 4 MB to 8 MB. So 4 MB to 8 MB. So some flavors, so it is from 4 to 8. So it is from KBs to MB. So each block size has gone up. So what happens when your block size increases is the question. What happens when your block size increases? So when the block size increases, obviously there would be a more room for processing of the data. There would be a more space for the processing of the data. So if you look at the different block sizes of different file system for the operating system. So here idea is you look at the kind of improvement in the block size. Now let us talk about Hdfs. The role of the block size is what? The role of the block size is it would actually help you to have more block size set for the processing speed, processing file, so that my processing would be little faster. So it's only how quick I can process my data. So here the point to remember is block size actually plays a crucial role in order to process a file. So no matter how big your file is, no matter how big your hard disk is, no matter how you have a good system, but if you have these configurations of, if you have a block size of minimum, then the processing obviously would be slower. So here now HDFS, here the block size is, that is what we'll talk about, that is the importance of the block size in an operating system or in a file system. Now what is the block size of HDFS? What is the block size of HDFS is important. The block size, the default, so when I have installed HDFS on my laptop, my block size by default is 64 MB. So from 512 to 4 to 64. So HDFS, the block size is so high when it comes to Hadoop distributed file system. When you take Linux or any other flavor of Linux flavors, you have 4 MB is the block size, 4 MB is the block size, but immediately when you look at the HDFS block size, it is increased to 64 MB. So we will see why block size is so high when it comes to HDFS. So obviously when the block size is high, I will have because here we are dealing with not the ordinary data. Here we are dealing with petabytes and zettabytes of data, or terabytes or petabytes of data. So when you are dealing with so much of big files, obviously this block size would help us to process the data very fastly. So that is the importance of a block size in HDFS. So this is the default block size of 64 MB. So that's how HDFS. So HDFS got something called Hadoop distributed file system. Now it has also got something called as distributed file system, and the file system has a wonderful block size. The block size of HDFS is 64 MB, and it is configurable. It is configurable. Remember, Hadoop is full of configurations. So how you want, why you want, everything is configurable. We can do a lot of configuration. So in fact we can say it's driven by the configuration. So Hadoop distributed file system. Now we'll talk about the architecture of the distributed file system later on. So Hadoop distributed file system, this is the importance. Why? That is the reason we have to study about. That is the reason why Hadoop distributed file system is making everything so quick, is because of its file system. So Hadoop comes with a wonderful file system called as HDFS. So we are going to learn about the architecture of HDFS in later sections. So one of the important points is of its block size, and also the factor of replication. There will not be any data loss, because by default you have a certain number of replications set when it comes to Hadoop distributed file system. So when we actually learn or go in depth of Hadoop distributed file system, we would be learning about Hadoop distributed file system. So here there are certain limitations, yes. Now the question comes is, what happened to the existing relational database models? Why we are looking at something else called as Hadoop framework, or why we are looking at something called as HDFS and MapReduce? So what are the limitations that you have for the existing data analytics architecture? So when it comes to here we'll understand is any data which comes from either different sources, any data which comes from different sources, actually you'll collect all the data, will collect all the data. So and whatever the data, either instrumentation, whatever the data that you get, you'll all collect it. So mostly what we'll do is we'll try to append all this data. Now before Hadoop actually come into existence, instance, there are certain groups who actually used to maintain so much of humongous data. So, we can call it as grid computing or high performance computing, high performance computing. So, now collect the data and you append the data to grid computing, where this is where we used to store all the data, whatever the big data that we have been dealing with. So, that we used to append the data. Now, what we will do after this, what we would do is we will move the data, whatever the data that we have in the grid computing. Grid computing is a process where you have bigger data sets stored and maintained in the servers. So, grid computing, the reason why we are mentioning is other than Hadoop. So, before Hadoop, what actually happened. So, grid computing and high performance computing. So, now this again move to ETL, I hope you understand what is an ETL. So, now who would be moving this data to grid computing. Now, we will be moving this data to grid computing. So, ETL again, that actually would be moved to RDBMS, and wherein we would be doing some business intelligence reports. So, business intelligence report, or else we will have this as something like this, RDBMS, and again you have all the BI reports, this is the traditional way, or the existing, what is the architecture of the existing analytics, data analytics system. So, the data whatever that we get, we used to collect and we used to append it to high grid computing or high performance computing. So, these are the storage mediums where you have all the data to be stored. So, you have so much of data. Now, what I will do is I will extract, transform and load into ETL grid, and again that would be going to RDBMS, and out of which I would be generating lot of BI reports. Here the problem is, this is this high performance this is only for the storage, this is only for the storage, yes, this is only for the storage. Now, here so here from here to here, when you are appending the data or when you are moving the data, all the data cannot be moved. So, you cannot move all the data. So, here from here what happening is, only here we cannot explore all the data that you have on grid computing models. We cannot explore all the data that you have on grid computing models. So, here for the business reports, here from grid computing, when you are appending the data, we cannot append the entire data. You cannot append the entire data. So, when it comes to business reports, only 10% of the data, being uploaded, only 10% of the data uploaded. So, or available data available for business intelligence reports. Now, here we have 100% of the data. So, we have something called as grid computing or high performance computing. So, we would be appending all the records, all the data that we have here, and out of which we used to take only 10% of the data, to generate business intelligence report or BI reports. The concept here is, though we can store, so much of data here, again there is a limitation, but if I wanted to move for the computation, or I want to do some analysis, I cannot append, or I cannot ingest, or I cannot use all the data that I have. Only 10% of the data that I can use. Then what happened to this 90% of the data? Either 90% of the data is archived, and 90% of the data is archived, and they would actually, they'll get a premature death. No one will actually care about this 90%. That was the current, that is the limitation of existing analytics architecture. So 90% of the data may, they prematurely die, premature death. That means it's of no use. 90% of the data is archived. That means it is of no use. Here, using different mediums, different models, whatever we used to get is, we used to move the data. So we could, move the data to the grid computing, and if we wanted to do any computation, I cannot move all the data. Because RDBMS has certain limitations which actually cannot hold huge amounts of data again. So if I wanted to generate any business related information reports, only 10% of the data is available. 90% of the data, we don't have any medium. Here the important point is, we are trying to move the data to the computation. Here we are trying to move the data to the computation. So imagine we cannot move. Let's say you are working in a company where you have different servers in different locations. So in order to deal with this big data, you cannot, if you wanted to move so much of data to other network or other server, which is a tedious process, which is in fact it's an insecure, cannot be actually done, because you cannot move the entire data to the computation. So in order to move the computation to the data, only thing we can do is only 10% of the data is feasible to move, because I cannot actually transmit or serialize or entire data from my location to another location. So for which, what I will do, I'll take only 10% of the data, whatever that I have, 10% of the data, that whatever that I have. So I'll move that data for ETL processing or to generate the BI reports. So then what happened to this 90% of the data? It will take a premature death. That is, no one will use that. So here the whole concept is, as we have been saying, in order to have your business have more revenues, we are not allowed, no company actually not allowed to lose the data, because again the old saying that we have, instead of customer is king, we now in this age of data will say data is king. So no company actually wants to lose the data. So 90% of the data, either it will take a premature death or no one actually would care about it. So these are the limitations. So now how Hadoop has shown a way in order to deal with this. Here grid computing or high performance computing was used only for the storage. So now here what happened is, in place of grid computing or high performance computing, we do have a wonderful platform. Which is called as Hadoop. And Hadoop is not only for the storage, and this is also for the processing. Now in this phase of computation, in this phase of sending the data, moving the data to the different resources, different sources. So what Hadoop can do is, actually Hadoop actually has come with a concept of moving the computation to the data. In the earlier versions, in the existing analytical architectures, what we used to do is, we try to move the data to the computation. But whereas Hadoop, in this Hadoop architecture or Hdfs architecture, we have a wonderful concept called as data locality. So what I will do, I will send my computation where my data exists. I'll send the computation. Let us say I want to do some analysis on a 1 TB of data, and I'm sitting in Hyderabad and my data is in New Delhi. So instead of doing that 1 TB come to my server, because while transmitting the data, anything can happen. So we are not afford to lose the data or no any other hackers to show our personal data of the computer of the company. So what I'll do is, instead of having that data onto my server, what I'll do, I'll simply write a program. I'll simply send that data to that particular logic or the program. In a way of simple language is a program or a process or a function or a method or a class. What I'll do, I'll write my class, function or method, and no matter how big your data is, the small amount of logic or the file that I'll send. So to send a small amount of data, I don't have to have so much of big bandwidth networks available. What are the existing networks that I have, I can easily send that my logic to that existing data. So this process actually called as data locality. Now when you look at this Hadoop, and this is a Hadoop is for not only for is for storage, it's for storage and also for computation, storage and computation. So now here, what are the data that we have? What we'll do is, here in this advanced analytical or combined storage computer layer, we call it as. So to avoid the limitation existing that only few amount of data can be analyzed, or to avoid that, to overcome that, now Hadoop or Hdfs or Hadoop has come with a wonderful layer which is actually called as Hadoop, which is for storage and also for the computation. So what is this? In this, what happens is, whatever the data I'll append it on Hadoop framework. So all the different forms of data, what I'll do is I'll upload it on Hadoop framework, and this is scalable for ETL, and that would be dealt with RDBML. So what happens is, when you have so much of data available here, so all the data is available for exploration. So here what we are doing, we are not sending the data to the computation. Instead, what I am doing is I am sending the computation to the data. So when that happens, what happens is, for all the BI reports, 100% data is available. So no data is lost. No data will take a premature death, because this Hadoop storage and the computation model actually speaks about the data locality. So I am coming to the data, my logic comes to the data where my data exists. So data exists in different geographical locations, no problem. I'll go to each and every node. That's actually what is parallel programming called as, batch processing is called as. So what I'll do is, my computation would go to different locations where my data exists and do my computation, and again I'll come back. So no data will be left without analyzing. No data will take a premature death, which used to be in the previous case. So 100% data is available for business intelligence report. So anything that I wanted to do, it's not that I'll take only certain amount of data. No, all the data is available, is because this Hadoop storage and computation layer. So this is very important. So no premature death. No data is archived, only 0% data is archived. There is no question of premature death. Again, what are the data that you have? Instrumentation or will collect the data and will append the data. In fact, not append, will store the data. So instead of saying what will think, so we'll move the data. We'll move the data onto Hadoop storage and computation layer. So Hadoop storage and computation layer, it is combined computation and storage layer. So what we will do is, in Hadoop, what I will do, I'll have my computation come to my data. So there is no loss of any data. In fact, 100% data is available for my BI report. So no data is archived, or we don't see any premature death of any data. This is very important. So what is the existing limitation what is the limitation in the existing analytical model says there used to be only certain amount of data, is because I don't have a concept of data locality. But with the introduction of Hadoop, we have a wonderful characteristic imbibed in Hadoop is Hdfs is something called as data locality. So this is very important term, data locality. Data locality. So this is how we can actually overcome. Here, when I say data locality, one more example that I wanted to quote here is, so Hadoop solved the problem of storage. Hadoop Hdfs, in a way of saying, Hadoop or Hdfs actually solved the problem of storage, and also Hadoop solved the problem of processing, and also Hadoop solved the problem of networking in the form of distributed networking, So when I say distributed networking, so that's what Hadoop allows us to do. Hadoop, let us say I have a file here, and as we have learned, each of my file, it's a vague example to make you understand. So each of file actually distributed amongst different machines. So each block actually would go block A, block B, let us see, and block C. Okay. So now I have written a logic. This is my data. So instead of this whole data, or instead of my let us say it's of 10 GB file, instead of this 10 GB file, or instead of this 10 GB file, or sending it to the logic, what I will do, I will break them into each of 2.5 or whatever, which is actually equal to this 10. So what I will do is, I will send my logic to each of my machines, and they would work at a time, they would work parallelly. So again they will give me some output, so this output again I will aggregate and give the final output. So final output. So here the point here we have to understand is, we are dealing with big data. Here. So instead of getting that entire data of GBs or TBs or PBs, what I will do is, I will distribute my data in form of blocks onto each individual system on my cluster. So we will be looking at what is a node, the terminologies of Hadoop, what is a node, what is a cluster, what is a rack. So we will be looking at all these things, how actually the blocks would be divided and kept in different nodes on a cluster. So we will be looking at all these scenarios. So here Hadoop actually breaks each file and keeps them into different files. So instead of the entire file going to the logic, what I will do is, I have my logic come to where my data exists. So this concept is called as data locality. So this is in form of distributed network. This is called distributed network. So these are advantages. Not only that, one of the best advantages that we have when you have your Hdfs or Hadoop installed is, you can have your Hadoop installed or Hadoop distributed file system on commodity hardware. This is also very important, commodity hardware. So in fact, Hadoop commodity hardware, that means, let us say I have a system of which is of the RAM size is of 1 GB. I have a system, the RAM size is 512. I have a processor of 5 years old, or I have a latest process. No matter how old your system is, no matter how small amount of data that you have, of course there are certain prerequisites in order to have your Hadoop installed, but on the commodity hardware also you can have your Hadoop installed. So these are the advantages that we have when it comes to Hdfs or Hadoop. The main advantage is it solved the problem of storage, it solved the problem of processing, and also it solved the problem of networking. We call this as a distributed networking, or in the form of data locality. Not only that, your Hadoop or Hdfs can be installed on commodity hardware, existing hardware. I don't have to invest more money on in order to have my infrastructure to make it a little advanced. I don't have to go and buy certain new infrastructure in order to have my Hadoop installed on my network or on the cluster. So these are the advantages, and also we will see certain disadvantages also. There are certain disadvantages when it comes to Hadoop as well. There are certain disadvantages as well. So we will be speaking about the disadvantages in the later sessions. So we will be seeing in the later sessions. Thank you.